I know that if I want to calculate the time through the distance and what do you call velocity, okay. So F is the distance covered is velocity times time, so the time is going to be the distance. So time is distance divided by the velocity, okay, distance divided by the velocity, okay. So imagine this is given that this person can run the boat at say 6 km per hour, okay, run the boat at 6 km per hour and perform the run so he can run the boat at 6 km per hour and he himself can run at say 8 km per hour actually. 8 km per hour. So the velocity to reach from this point to this point is going to be 6 km per hour, and to run between D to B is going to be the 8 km per hour actually, okay. This is what it is going to be. You can actually see that with this number it is best to go for this strategy. The others are going to take more time. You can check it. I'm not going to get into that detail, but you can check that if you take the other paths, that would be a big trouble. You're going to take more time to reach from A to B. Anyway, so the time to reach from A to D is going to be the distance between A to D and the velocity with which this person rose from A to D. The velocity is given to be 6. What is this distance actually? So for me, this is a right angle triangle, okay, right angle triangle. So if this distance is x, this is 3, so this would be square root of 3 square plus x square. So it's going to be 3 square plus x square, which is x square plus 9 divided by 6 actually. And the time to run from B to D is going to be the distance, which is 8 minus x kilometers, divided by the velocity, and the velocity of what do you call his running speed is 8 kilometers per hour. So it's going to be 8 minus x divided by 8 kilometers per hour. So in other words, this time to go from A to B is a function of these two variables, x plus 9 over 6 plus 8 minus x by 8 actually. So this is a function of x actually. So what we want to do, we want to minimize this time. We want to find a location x, find a location D at a distance x from C such that this time is minimum. So what should I do? Do your optimization technique actually, and that is going to give an answer to this very interesting kind of a problem actually. So let's compute say TAB and its derivative. So what would be the derivative of it? So the derivative of say d by dx, so we're going to calculate say x square plus 9 power 1/2 plus say 1 over 8 times g by dx of 8 minus x. Okay, this is what is going to be really the derivative, 8 minus x. Okay, and this will be 1/6 times 1/2 x square plus 9 1/2 minus 1, so it's going to be negative 1/2 okay, and times 2x plus 0, plus this will become 1 over 8 times 0 minus 1. So let's calculate this derivative. So it's going to be, you can see that this 2 will be cancelled with 2. So you're going to get 1 over 6 is square root of x square plus 9 plus 1 over 8 minus 1 over 8, and let's equate this to 0 and solve this equation. So this is going to be, so if I take this on the other side, you're going to get this equal to 1 over 8. So if you, for example, take the reciprocal, x square plus 9 equal to 8, and say you square both sides, divide by 6, so you're going to get 8 upon 6, and if you square both sides, you're going to get x square plus 9 equal to 8 over 6 square, and if you simplify this, you're going to get x square equal to, so I have made a mistake that I need to put an x because this x is going to be there, okay, and therefore this is going to be, what do you call it? So if x is there, so let's put x here actually, okay, so if you're going to take reciprocal, you're going to take reciprocal, 6 times of x square plus 9 divided by x, and 1 over 8, 8 over 1, so this will become 8, and if you simplify it a bit more, so it's going to be x square plus 9 equal to 8 over 6 times x, and then square both sides. You're going to get x square plus 9, 8 over 6 square x square. You take this x square, subtract it from here, do the calculation, it turns out that the value of x that you're going to get is really 9 over square root of 9 over square root of 7. So this is going to be the value at which you get your t prime is going to be maximum or minimum, we don't know, so it's a critical point. So in order to do this, what we should do now, so let's get rid of this part and let's try to figure out what would be the second order derivative. So the first order derivative is TAB, okay, T prime of AB of x equal to, so if I simplify this, you're going to get x over 6 square root of x square plus 9 and minus 1 over 3. This is what is really TAB. Now, if you, by the way, if you think about, so the one way could be that you compute the second order derivative and substitute the value, and you will see that you're gonna get the your TAB is going to be minimum. So in other words, your second order derivative, so in other words, you compute T double prime of AB and substitute, say, this 9 over square root of 7, you're going to see that this is a positive number. It's a positive number. So therefore, x over 9 over square root of 7 is really the minimum point of the TAB. But I would like to do this problem in a bit different way. Think about it. Why? Because for this problem, my x In other words, this point D can be what potentially point? It could be a point, you can take a D to be C or up to what do you call B actually. So at worst, at extreme case, this D can be C, or it could be B, or it could be some point in between actually. In other words, this X can be in worst 0, or it could be equal to the entire 8, or it could be some point between 0 and 8 actually. So my point is this, for this problem we have been given a closed interval actually, that my X, in other words this X should be a number between 0 and 8. And if you have been given a closed interval and you know the critical point, then you know that it is, you can apply the closed interval method to find what do you call your minimum or maximum point actually. Okay, so what we can do, so let's apply the closed interval method. Let's calculate say TA of 0. So if I substitute this endpoint in this, the value that I'm going to get is 1.5. I'm not doing calculation. And if you substitute say TAB of say 8, okay, so this is going to be equal to 1.42 approximately. And if you compute, for example, TAB, okay, you're going to get if you substitute, for example, this 9 over square root of 7, you're going to get what do you call, you're going to get equal to 1.33, 1.33 actually. Okay, this is what is really the point X actually. So TAB, if you substitute this, you're going to get 1.33. So what does this show actually? So this piece of information gives you another interesting information. So if you want to come through the B through this path, say going forward with the C and then coming up B, you're going to take this time actually, 1.5 say hours to reach from the point A to point B. But if you take a direct path of going from A to B, in which the case, this means that the D is the point B and X is equal to 8, okay, then the time that you're going to get is 1.42 hours. But if you come at a point, location X, where X is this 9 over square root of 7, then the time that you're going to take to reach from A to B is going to be 1.33. So in other words, it's better than other two methods to go for this path actually. That go for this path, and then you know, but basically this value is I think 3.4 something actually. So this X is really 3.4 kilometer. So it's around 3.4 kilometer actually. 3.4. So go to the point D, which is a 3.4 kilometer away from C, and then run for the 8 minus 3.4 kilometers actually. So, and that you will reach in a minimum, the person will reach in a minimum amount of time actually. So see, it's a very interesting problem in which we kind of went through the process of modeling and how to write the equation, and then we found what you call the solution. What would have been the disadvantage of calculating the second order derivative and substituting X equal to 9 over 7? Okay, it will tell us that okay, you're gonna reach from the point, the minimum point in time would be 1.33, and the minimum time that a person can take to reach from A to B is going to be 1.33. But we would not have convinced actually that why these two paths going from A to C and C to B and directly going from A to B is not a good idea. Is not a good idea. Okay? In this method we actually see the times actually, precisely. that okay, if you take this path which goes from A to C to direct B, you're going to take 1.5 hours, 1.42 hours, so the best is to go through this time. So I hope this is making a bit sense to you. So the problem goes like this. Imagine you have a circle, okay, and in this circle has a radius, for example, r. Okay, this circle has a radius, what do you call r? In this circle, say I want to draw a rectangle, okay, or maybe you have been given, for example, okay, so it's not full circle, but it's a semicircle. So it's a semicircle with the radius r. Okay. Now, in this semicircle, I can draw, inside the semicircle, I can draw different rectangles. This could be a rectangle, this could be a rectangle, but I want to draw a rectangle, okay, that has a maximum area, that has a maximum area, and it lies within the circle edge. So it's inscribed within the semicircle. So I want to draw a rectangle with a maximum area, you know, as big as a rectangle, a rectangle that is as big as possible and lies within the rectangle, within the what do you call circle actually. So the best would be to choose some point carefully on what do you call the circle in such a way that that this rectangle touches at those points of the circles and covers the maximum area actually. So it's going to cover the maximum area if you're going to draw a rectangle whose, say for example, width is touching the circle at 2 points, okay, and you know also the length. So this is what is going to be really the idea. So let's call this point as, say, x, y. So this distance is really y, okay, and this distance is x. So the total dimension of what do you call this inscribed triangle, so if this distance is x, this is also going to be x actually. So the dimensions of the circle are x plus x, x plus x and y. So these are the dimensions of the circle actually. Okay. By the way, if this point is xy, this point is going to be negative xy. That's another interesting thing. So let's think about the area of the rectangle. What would be the area of the rectangle? The area of this rectangle is going to be the width multiplied by height. So in other words, x plus x multiplied by height into x. This is what that you're going to get. Okay, where x and y are the coordinates of this point. Again, we want to maximize this area, but this depends on two variables. So I need to get rid of one variable. And how can I get it? I know about this point, that this point xy also lies on the circle, semicircle. So if it lies on the semicircle, it's going to be x square plus y square equal to r square. Okay. And if this is the case, then I can get, for example, the value of the y from here. So it's going to be square root of r square minus x square. I can't take the negative value because then area would be negative. So the only possibility is to take the positive value of r square minus x square. So the area then is going to be 2x times square root of r square minus x square. Okay, so this is really the area that we would like to maximize. Okay, we would like to maximize. What would be the relationship, for example, between x and r? I mean, if you think about it, this distance x can be, say, for example, if you so it could be something between 0 and r actually. So if this is 0 and this value is r, then this distance x is something between 0 and r. So I can say that my x lies between 0 and the radius r. Okay, so that's maximizing. So if I maximize it, what are you gonna get? So let's now compute the derivative of this. So you're gonna get 2 times of derivative. So if I call this as u and call this v, so this is going to be 2 times of r square minus x square, okay, and minus plus 2x multiplied by the derivative of this. So you can calculate this derivative. This is going to be minus 2x square divided by, r is going to be, sorry, x divided by square root of r square minus x square. I hope you get it. Why? Because if you take, say, r square minus x square power 1/2, so it's going to be 1/2 times r square minus x square power minus 1/2 times 0 minus 2x. So you can get rid of 2 and 2 and you're going to get this derivative. So if you simplify it a bit, so it's going to be 2 times of r square minus x square and minus 2x square over r square minus x square equal to 0. And if this is the case, if you simplify it a bit, 2 times of r square minus x square and say 2x square over r square minus x square, you multiply them, so 2 times of this is going to be r square minus x square equal to 2x square, and this is going to be 2r square, 2r square and 2x square. If you divide, for example, both sides by 2, so you're going to get r square minus x square equal to x square, and so 2x square is r square, so the x is really r upon 2. Okay, so we will not take the negative value because x has positive coordinates actually. Okay, the x is non-negative, so it can't be 0. So what we should do, again, we have a critical point and we have a closed interval known to me on which the function is defined at. So I have 2 ways to do it. I calculate second order derivative and then substitute r over 2, or if the domain of the function is given to you, then you can apply the closed interval, or what do you call, method. So if you substitute, for example, a of 0 endpoint, you're going to get 0. If you substitute, say, a of r, the other endpoint, so it's going to be 2r times r square minus r square, which would be 0 again. And if you substitute, say, a equal to r upon 2, so you're going to get what? 2 times of r upon 2 and square root of r square minus r square upon 4. Okay? And it's going to be 2, so r square root of this will become 4 minus 1, so 3 upon 4 r square. You simplify it, square root of 3 upon 2. This will become r multiplied by r is going to be r square. So this is, first of all, this is the biggest value